we're asked to reduce, if possible, this fractional expression. In order to reduce it, we first factor both the numerator and denominator and then see if there are any common factors that can then be divided out. Well, the numerator doesn't factor over the integers. Matter of fact, it doesn't factor over real numbers at all. As you can tell by plugging these coefficients into the quadratic formula, you would end up with a square root of a negative. And that's simply not going to result in any integer, rational, or even real factors. Anyhow, we can prove that this isn't factorable, and you're not going to be able to find a way to factor it. Denominator, of course, factors into x minus 3 times x minus 2. But the numerator doesn't factor, so there's no simplification. So this doesn't simplify, except perhaps if you consider the factor denominator to be a simplification. And for most applications you would. So we kind of want it in this form, but there's no other simplification. Okay, in the case of this expression, it's easily factored. X squared minus 9 is x plus 3 times x minus 3. X squared plus 5x plus 6 is x plus 2 times x plus 3. Now, you're going to want to draw lines through things and do that thing they call canceling. And I really dislike canceling because nobody ever does it right. It's always done like this example over here. You got x minus 3 over the quantity x minus 3 squared. You cross out the x minus 3's, you get a blank up here and a blank here, but with an exponent 2. That's the kind of cancellation I'm used to seeing. That's why I dislike cancellation, and I don't talk about it very much. So what do we do if we don't cancel? Well, we go back to the fundamental rules. Cancellation is not a rule. Cancellation is a trick. It's a convenient trick if you know what it means and how to use it. So we're going to go back to what it means. Okay, we've got this over this. Now we can clearly rearrange this to where we have the x minus 3 followed by the x plus 3 in the numerator, so that the x plus 2 is followed by the x plus 3 in the denominator, and we can write this then as x minus 3 over x plus 2 times the x plus 3 over x plus 3. We really don't have to do any of that just to rearrange this, but it's very clear that this expression is identical to this one. Okay, and having done that, x plus 3 divided by x plus 3 is 1, and then x minus 3 over x plus 2 times 1 is just x minus 3 over x plus 2, which is what you would have gotten if you had canceled correctly. Okay, I've seen people try to cancel the 3 here with the 3 here. I don't like cancellation. Until you really understand the fundamentals, nobody should ever use cancellation. It's merely a convenience, and in Virginia, so people can circle the right number in the SOL if they happen to remember to do it right. Okay, well, anyhow, this is what you end up with. Okay, another expression. Now, this is a multiplication. So, well, we're going to still factor these two terms of the fraction, the numerator and the denominator. We're going to get x plus 1 times x plus 2 for the numerator, and x minus 3 times x minus 3 for the denominator. We could, of course, write this as x minus 3 quantity squared. And if you have like an 8th power or something, you really don't want to write the thing out 8 times. But right now, we're trying to focus on what things mean, so I'm going to write the x minus 3 twice. Later on, we'll go ahead and use exponents, but that confuses the issue at this point. Okay, or at least I'm afraid for some of you it will confuse the issue. Well, we can now write this as x minus 3 times x plus 1 times x plus 2. Now, I've written the x minus 3 on the end, but it's clear that I can do that. Multiplication is commutative and associative, so we can put the x minus 3 on the end. And, of course, in the denominator, if we just write it in the order that we see here, we get an x minus 3 on the end. So that we can pretty clearly see that we have an x minus 3 divided by an x minus 3. But, of course, we also have this x plus 2 that matches this x plus 2. So I can bring the x plus 2's over toward the end, and I can say, okay, I've got an x plus 2 times x minus 3 in the numerator and an x plus 2 times x minus 3 in the denominator, and now I can write the expression like this, and I can divide this by this to get 1, leaving me x plus 1 times x minus 3. Okay, again, all done without crossing stuff out. I don't like crossing stuff out. If you do it wrong, I penalize it pretty strictly. You're better off not doing it at all at this stage.